What's up, guys? So, welcome to episode three. As I've mentioned, from episode one to episode two, those were like foundational levels of concepts for leaders to make a judgment between modular architecture and cloud native decisions point of view. So, let's take a look. What does observability at scale mean in terms of building system in this episode? Right. Basically, that talks back to the series that I'm trying to build in this playlist, which is a modern systems and real impact point of view. So let's get into the details, right? So when your platform actually handles millions of users and terabytes of data and thousands of requests per second, logs alone won't save you, right? But at the same time, observability isn't about building dashboards in order to trace and debug the issues when the complexity gets out of your hand and control. It's about designing the systems that actually helps you to trace through and talk back clearly at scale and in real time, right? So in this episode, I'll break down how to design for observability in high scale systems across microservices, data pipelines, and AI platforms. You can lead with clarities and not with any ambiguities involved here. So let me quickly share my screen to reflect a simple depiction of what I'm referring to. Right. So let's review what I'm trying to refer here, right? So why observability breaks at scale? If you look at here, traditional monitoring tools break down with your service count, right? As your service increases or the data volume explodes, right? We are trying to deal with, if you look at Netflix, Amazon, Uber, and many other such companies, the voluminous data that we would have to manage. You need to make sure your replication factors, your shard mechanism, partition mechanism, everything is being accounted based on the frequency of the request and the volume of the data, right? So metrics lose meaning without labels and cardinality and right. So because you have some metrics, but you don't have like a segregation of what that metric indicates will become difficult. And again, at the same time, tons of logs is actually a noise, but how do you leverage it, right? And that is, you have to manage multiple alerts, right? So, example, a multi-region data ingestion pipeline running about like say 150 plus microservices, where S3 input-output latency caused cascading lag across multiple Kafka clusters that you're trying to handle in a distributed messaging environment, right? So without structured traces, all you see is the timeout errors, not the root cause. So although you have these microservices, you have Kafka clusters, you have S3 to handle what kind of object storage you're trying to deal with. But observability also, breaks at scale depending on how we handle it. So it's important for us to understand, right? How to evolve at scale. Let's these three pillars that I'm referring to, the metrics, the logs, the traces, um, it's important for us to design it well. Like when it comes to metrics, let's say you use Prometheus with high cardinality labels for API latency, queue depth, right? And the database saturation. So include histogram buckets to analyze like P95, P99 trends. And when it comes to logs, maybe use structured logging like JSON and correlate with trace IDs, right? You can centralize this with your um, Kafka or Elastic cluster or Splunk. So you can query them with IDs, attributes of the JSON, I mean. And next, traces. Use OpenTelemetry to auto-instrument these service calls, your database queries, and queue spans. Exporter tools like Honeycomb or Lightstep. So, what I'm trying to highlight overall here is the goal is not just to collect, it is to stitch, correlate, visualize end-to-end behavior across services and time windows, right? So you need to consider the stage of big data plus the observability. At big scale, observability is a data platform or the data problem, right? So use log indexing pipelines with sampling, right? And different tiered storage to manage these logs, like hot and cold tiers in Elasticsearch or Snowflake, and build the rollups and the aggregations, store logs, let's say for 2 days, metrics for 30 days, depending on what these are just some samples I'm giving you, but decide on the retention thresholds accordingly, right? Or when it comes to anomaly threats, maybe you want to store it forever depending on your audit compliance rules or legal team their thought process in terms of what works depending on GDPR complaints and PI data for how long the data has to be retained to trace the historic audit activity, right? And AI ops, like obviously train models on historical trace patterns to detect any kind of a drift involved, anomalies, or silent failures, right? Example, ingesting 5 terabyte of telemetry per day across 200 microservices in 3 regions, right? You built a custom pipeline with Kafka and plus choose a platform like ClickHouse or any other component for interactive querying with less than 1 second latency. So, and basically, if you look at this diagram, how it's depicting the three-tier observability plane, right? The collection layer, transport layer, storage plus query layer. In the collection layer, you have agent SDKs, sidecars, and collectors, file beat, transport layer, Kafka, right? OLTP, and storage has storage plus query layer, depending on how you want to manage your metrics in Prometheus, Grafana, and how you want to look up your JSON-based logs, all that matters. Consider the designing these three pillars for your observability plane, right? The collection layer, transport layer, and the storage and the query layer, right? And use your, for example, in one of the projects that I had worked on for collection layer for in order to build a data pipeline, we leveraged the WAN-DB, the weights and biases, in order to understand which data point was traced by which model, right? So that legal team had a dashboard to go and visualize to understand GDPR compliance point of view. Later, if they decide that this particular data is not supposed to be used anymore for processing, we can go back and trace the based on the ID and make sure we clean up historical, right? So that was one good example, and the implementation that we incorporated, and we had our own SDK that we built for WAN-DB and leveraged those endpoints and built a customer reports plus the integration with annotations in the code base based on the different stages of the data pipeline. So that's one example. So similarly, you can consider to build different SDKs based on the pipeline that you're managing with for the data at scale. Now, so you can use, like I just mentioned, right? So use your trace IDs, decide what is the trace IDs plus the request IDs that flow end to end through headers or through your requests, unify logs, your metrics, traces, and centralize your dashboards, right? Grafana plus trace linking different plugins for your click throughput root cause point of view. And your resilience patterns also is important. What kind of back pressure mechanisms you're having, retry mechanisms, circuit breakers integrated with your alert logic, right? So overall, observability at scale isn't just about like an uptime. It's about insight that will help you recover in resilient manner for the root cause discovery, right? You're not just collecting the data, but you're building a system, one that alerts, explains, and evolves with the volume of the data as the business complexity evolves too, and the use cases evolves too. And so if you're a leader and if you're leading teams, designing platforms or scaling data pipelines, leverage some of these pillars I'm highlighting for the observability in terms of collection layer, transport layer, and storage or query layer. That will help you stay ahead of failures, right? So subscribe for the next episode where I'm going to highlight where we can discuss some of the pointers, excuse me, to understand how we tackle the difference between AI platforms versus AI features and how leaders should evolve in terms of designing for AI native architectures. So, having said that, it's important that you make your judgments accordingly. Stay tuned for the next episode. And again, don't forget to subscribe and leave your questions in the comment section. I'll talk to you soon.